So, hey everyone, I hope we are live. I guess so. And am I audible first of all? Because I'm trying a new mic, so I just need to know if I'm audible enough. So, yeah, let's see. So, hey, hello, Suman. Mm, so yeah, my name is Palak. Okay, hi Palak. I'm sorry for calling you Suman because your username is Suman, right? So that's why Palak. And Satyam is here. Hey Satyam, how are you guys? How are you guys, man? Yeah. Here we have a few instruments. So I guess we shouldn't wait much time because it's just a 1 hour session, right? So we should directly dive into it. So and in every weekend we'll be definitely meeting for a 1 hour session like this. So in this particular video, as the title says, so happy Diwali, Vishal. Happy Diwali, everyone. Can I say it belated or something like that, or whatever it is? Hello, Akshay. So let's just discuss why you people are here actually. So am I audible, right? Yeah, this is the first session, Suman. This is the first session. This is the introduction session. So most of the time we'll be discussing about what we'll be doing in the next couple of, or not couple, maybe I'm planning this to do in 7 or 8 YouTube sessions. So because it's an entire project that we are planning to do, so we will talk that like right away. So Pritam is here. Hello, Pritam. So I guess that's enough. Let's just dive into it, right? Uh, so, so yeah, my screen is visible, I guess. First of all, welcome to digital image processing. Right, that's necessary. So, so what we'll be doing in this particular series of videos, first of all, this will be a series of videos, and we'll be meeting every weekend at the same time, and like Saturday and Sunday, so both days, we'll be meeting at the same time, and we'll be talking about something that we want to do, and what is that we're going to do is to learn some cool image processing techniques. So first of all, tell me how many you how many of you, hi Mike. So how many of you all know what is digital image processing? Anyone has got any idea about what digital image processing is? Let's just don't go with that GIF. Just let's just not go there. We will come back there later on in the discussion. So how many of you know what digital image processing is? So that's it is here. So yeah. So if you don't know it, that's fine. I mean, that's why you people are here, right? So digital image processing is basically nothing but whatever you see these days. You have images in your mobile phone, right? That's a digitized image. So so things like you can say pretty much editing or blurring images, or you put your filters in, or sometimes what you do is if you people have definitely used either Teams for your online classes or Meet, there is an option where it says blur the background, right? So that particular system has a lot of image processing in it, but there are some different components as well in there. But image processing is basically nothing but fiddling around with the image, the digital image. That's what digital image processing, right? So it basically started, I guess, in NASA or something like that. So those people were actually looking into the signals that came from some rover, and what they wanted was, okay, what this particular rover is sending us. So that's a signal, that's an analog signal. They wanted to convert to a digital image. So that's when it actually started. Fine. So yeah, so digital image processing is nothing but whatever you see these days in image format, they are digitized. And if I want to, add in some things, remove some things, either degrade it or maybe enhance the quality so that I can later use it for some other purpose. All these comes in digital image processing. Fine. So what are we supposed to do with digital image processing? But we will learn a lot of digital image processing in these set of series videos. And what's the goal exactly? Like there should be a goal, right? There should be a goal first of all. So the goal is to build a project, a simple OCR calculator, and this GIF basically tells it. And I guess you people know what OCR is. OCR is optical character recognition, right? So it's nothing but given an image with some handwritten stuff or some printed stuff. What I want is I want to digitize, or I want to make a soft copy of it such that those content that's written there is digitally written in our system. So if I say 1 plus 2 into 8, that's the particular image I wrote it yesterday, I guess. So if I run an OCR in there, then I will get an output like 1 plus 2 into 8. So now it's digitized format. Now I can use it, either calculate what the value is and do a lot of stuff, right? So basically Google Lens is a very, very advanced version of a simple OCR that we're going to make. But the underlying, the underlying components of an OCR is pretty similar. And that's what we will be discussing through the entire series. So what we exactly want to make is an OCR calculator, not just a simple OCR, but an OCR calculator. So what is that OCR calculator? It's pretty simple. If I say 1 plus 2 into 8 and I click a picture and I give it to my system, it should detect 1 plus 2 into 8 and it should calculate 1 plus 2 into 8, which is 17. So if you are thinking 24, then I'm sorry. So 1 plus 2 into 8 is 17. And you definitely have been, these kind of questions are definitely there in Instagram, I guess. If you remember, they say only 20% of the entire universe, or the entire universe can answer this question. It's really tough. You are really genius if you can answer this. And I can say it's 17 because I wrote it yesterday, right? As I said. So 1 plus 2 into 8 is 17. So what I want to do is I want to project the answer, which is 17, into the page. And it's not actually in this particular GIF, right? So it's an incomplete project, but the main essence is clear, I guess. What we want to do is we want to detect whatever is written there, and we want to recognize whatever is written there, and then what? We want to compute what is written there, and whatever the answer is, I want to project it into the sheet. So that's what an OCR calculator is. So its use is nothing, just learning purposes. But for making this entire project, there are a lot of things that we will discuss, and that is the major advantage of doing the entire series, because there are a lot of image processing techniques that you need to learn to actually accomplish this, and those techniques are what is important, and that will definitely come in handy with any of the projects that you're doing actually. So if I'm not wrong, most of your people are using LinkedIn, and in LinkedIn there is like, I don't know, it's around a month or so. There was some project in which you show the Sudoku grid to the computer, then it fills the Sudoku. Like if you have seen that. So all of these, OCR kind of stick and detecting things and recognizing text and stuff like that. All of these are using a similar technique, and that's what we will be discussing to make this particular project. So advantages, as I said, first of all, you will be learning what is under the hood of an OCR, or an OCR is optical character recognition system. So if you people are doing some image processing things, so you might be knowing about Tesseract. Tesseract is a Python library. It is a go-to system for optical character recognition. So what you do is you put in your raw image and you expect the magic to happen, but most of the time in most of the use cases, you won't get a result which is as soothing as you expected. But and then you need to do a lot of pre-processing, and then what you do is if you are not getting the results, you go to the Google and then you Google it some blogs. You will get some blogs where it's written, okay, these kind of pre-processing steps need to be done, and then you learn about those pre-processing steps. So all those things will be done in this particular series. So yeah, so whatever is under the hood of a Tesseract or under the hood of any OCR system, we'll be discussing that, and all of the accompanied image processing techniques that will be very handy to do. So we already discussed it. So how are we planning to do it basically? So we'll be planning to do, I basically planned to do it 7 video series. So 7 video lectures. You can call it lectures or YouTube sessions. So we'll be doing that in 7. So in the first one, which is this one, which is Introduction to Digital Image Processing, that is DIP. Right. Yeah, somebody said DSP, DIP. Yeah, basically that's it. So filtering in images will be the second one, which will be next Saturday. So we'll be meeting then for filtering in images, basically blurring and sharpening. And you definitely have done blurring, right? So that particular thing will be what we'll be doing. And then we'll be seeing image gradients. So these words might not make sense now, but just, I would say be with me, you'll get it. And it's pretty interesting. It's really good. And then image thresholding comes in, and O2 thresholding, whatever it is. And then morphological operations. So morphological, basically the word is really good, right? It gives the essence. So morphological operations, as it sounds, is pretty good, but it's not that tough as it sounds. And pattern recognition. So we will do a video on pattern recognition. We will just simply touch a DL for computer vision, just touch it out, like skid it out. Fine, because we can't do the entire DL or the entire computer vision or even the convolution neural networks in a 1 hour session, right? So just touch it out because we have used convolution neural networks in this particular project that you are seeing here in this particular GIF. And then we will have the final session in which we will put all of these things that we learned together, and we will make our very own simple OCR calculator. Fine. So the major question comes. Okay, now we know how we're going to do it and what we're going to do it. But now the biggest question comes: what are the prerequisites? Right. So, am I not audible? I guess. Sorry. So, is it fine now? Is it fine? I guess it is now because my headset. Okay. Anyways, so I will increase my volume as well. Some technical issues. So yeah. So now the biggest question is, you might be asking, what is the prerequisites? Fine. So the prerequisites are nothing but you just need to know how to run a Jupyter notebook and some Python syntax understandings and how to use pip to install a new package, because we'll be using OpenCV and NumPy and some NumPy operations. If you don't know what NumPy and OpenCV is, we will definitely discuss that. But we need to know what? We need to know how to use Python and Jupyter notebook. So here, this is a Jupyter notebook that I've opened in my VS Code, right? And if you don't know this one, I would just be with me, because opening this Jupyter notebook in a VS Code environment is not that tough. You can basically do that in this particular weekdays that you're having. So whatever you must be knowing is, one is VS Code, fine, and VS Code or any editor that you want to use. You can even use Notepad, but that's not recommended. So, and the second is Jupyter notebooks, how you use Jupyter notebooks, and the third one is just simply Python. That's it. Because we will be then doing some from the very scratch itself. So this particular video is all about introduction to DIP and getting familiar with OpenCV. So let's just do that, right? So first things first, let's just discuss about NumPy. NumPy is a package. So if you people are doing along with me, then you need to install it, and you can say pip install NumPy, NumPy. I guess I'm not doing it yet. NumPy, and I can just simply run this. Mine is already installed, so it says, okay, requirement already satisfied. I believe that's what it says. That is what it says, right? So let's see, yeah, requirement already satisfied. And in yours, you will be saying, okay, it's downloading the packages or using the cache or whatever it is. So NumPy is installed. So what is NumPy basically? NumPy is nothing but, let's just say I have two lists or two arrays. In C++ or things, we call it arrays, right? So let's just call we have two arrays and, or two matrices. What if I want to multiply two matrices? I take the dot product of two vectors. So if you remember, if you have done some courses in algorithm design and analysis, you will see that, I guess it's in that subject only, you will see there are multiple methods for matrix multiplication, right? So in which the complexity is not n cube or something like that. So the reduced complexity or things like that. So NumPy basically implements all these kind of accelerated computing steps, so that you can multiply two matrices with ease, no matter how big it is. So that's how it does. It does multiprocessing and training, a lot of stuff. So NumPy is nothing but a package that lets you do numerical computations in arrays pretty easily and pretty efficiently. That's what NumPy is. So now you'll be like, when we'll be actually going through some of the steps that's required, and you will be saying, okay, it's pretty easy. Fine. So before going into NumPy, let's just talk about a very simple order structure, which is list in Python. So this is how we'll write a list, right? Okay, 1, 2, 3, 4, and 5. This is our list. If I say list, this is our list. So, are you people aware of 1D list, 2D list, or things like that? So this is a 1D list, right? I hope you people must be aware of this, because if you know Python, then you definitely know what a 2D list or a 3D list, things like that are. So this is what a 1D list, and this 1D list has how many elements? 5 elements. And let's just make L a 2D list. 1, 2, 3, and 4, 5. Okay, I just missed. Huh? Now L is what? 2D list. Now what do I have? I have 2 rows, and basically it's inside a list, and inside list a list, right? So this is what a 2D list looks like. And if I want to put 3D, then I'm gonna change this one that is in the first element with to a list again. So it's embedded list again and again and again, right? So nesting of lists. So it's what we call 1D and 2D. So let's just say I want to take all the elements. So how this looks like, how this should look like, is something like this. I'm saying L is here. So L is, how should it look like? I said 1, 2, 3, 4, 5, 6. This is the behavior that I want. It's the behavior that I want. And if I say, okay, this is columns, right? This is columns, this is columns, and this is rows. Fine. So if I say, okay, get me all the elements in the first column, how will you do that? You will loop over everything for I in whatever it is, range, I if you go 2, and for j in range, and then you say, okay, if I equal to or j equal to 0, then take that element and do sorts of things. So it's a bit cumbersome, right? It's a bit cumbersome, and it takes a lot of effort and time as well. So what's the best way to do is to use NumPy. NumPy gets you this very easily. So I will just give you an introduction as to NumPy, because I need to I'm assuming that you must know NumPy a little bit, because we can't actually discuss everything in 1 hour, right? And we eventually want to make an LCR. So I can't just simply say, okay, let's just discuss NumPy. So those people who are very new to this, yeah, we can mine, but I'm expecting like some people are here, so they will feel very, ghosted out of the things that we will discuss further on. So that's why I'm just simply skimming over all these little basics, so that we can start with OpenCV and then things like that. So those people who know how to use OpenCV and NumPy, they can actually skip this session, because that's not much other than introduction to this session. So so if you actually know, yeah, I will make sure that works, man. So so yeah, so in this particular video, we'll be just doing the introduction. So if you people are aware of NumPy, Jupyter Notebooks, and OpenCV, you can just simply next week. So that's when we will actually talking about new things and new stuff, right? So yeah, so this is my list. So I want that particular behavior that I actually wrote in the whiteboard. This one, right? That's where NumPy comes in. So what I want to do is first import NumPy. So I'm going to give it an alias, which is NP. And why NP? Because that's the general rule among people who do data science and machine learning. Right? If you don't do it, then you go to hell. That's the general rule. So if somebody sees you import NumPy or something else, then they will take out their knife and they will cut it. That's how the community works, right? So you have to do import NumPy as NP, and then what? NumPy.array is the function that I want to convert any list into what? A NumPy array. So what is the advantage of converting and say NumPy array, and I will say, okay, NumPy.array. So now I can say, okay, what is NumPy.array? It's 1, 2, 3, 4, 5, 6, exactly what I want. And if I want to say, okay, give me the first row, all the elements in the first row, I could say this. If I say all the elements in the second row, I could say this. If I say all the elements in the first column, then I would say, okay, get me all the elements in all the rows, but just the first column. 1 and 4. Second column, yeah, second column. And obviously, third column. Indexing is n-1, right? So I'm expecting that you know that as well. So yeah, so NumPy.array, we see that's exactly what we want, and slicing operation and things like that. And I won't be going into that basics, because you should do that. And there is an entire week ahead of us before the next lecture, so that you can get accompanied with that. So just NumPy array is nothing but, you can say, list only, but an advanced version of list. And don't go with the word. I'm just making it easy for those people who are very new to this. So NumPy array lets you do all sorts of things very easily, right? That's it with NumPy. I just want to give you an essence. Now comes the major part, the major giant in computer vision, which is OpenCV. OpenCV is a module in which is available in C++ and Python, and I guess in Java as well. And that's a giant. Like it's one of the it's the only best image library out there, I would say, after Pillow. I'm not afraid to say this, but anyways. So for doing OpenCV, what I want to do is I want to install it first, right? So this is what you do. Pip install OpenCV Python. Right. So you say pip install OpenCV Python, you just install it. I hope it's already installed, and it will say requirement already satisfied. So let's see. I hope I am audible enough. Next time, I promise I won't be coming with this kind of sound quality. I don't know what happened. Maybe some hardware issue. So anyways, so pip install OpenCV, say it says okay, requirement already satisfied. Now how do I import this? The import is not OpenCV Python. It's not OpenCV Python. It is CV2. And so I just imported it OpenCV2. And CV2 has a lot of functions, a lot of functions. But the first things first, let's just load an image. So I have an image here. This one is it. It's a random image I googled. It's a cute. What do you call it? Yeah, ducklin. Ducklin. That's what you call it, right? Ducklin or something like that. Ducklin is. I don't know what happened to my vocabulary. Anyways, so we need to load this particular image. So load an image. The function is imRead. And you know what takes imRead? imRead takes the path to this particular image. So my particular image is random image.jpg. If I run this, you'll see, okay, I got something called array. So let's just go back a little second and see, okay, if I convert any iterable to a NumPy array, it also says array. So whatever we got here is a NumPy array. How do I confirm that? I can just simply say type and dimensional array. So that's why I just gave you an essence of what array is. So this just gives you a NumPy array. So let's just store it into a variable called image, and then just see what image looks like. So we already saw, okay, this is what image is. Right. So now let's just say how do I know if it's loaded into my image? So I want to see this particular image, right? So there is function for viewing the image that's loaded, which is show, and it takes what? A window name and an image variable, you can say. But we won't be using this. You know why? Because I'm using what? Jupyter Notebook. So imshow basically generates a new threaded GUI kind of stuff, a window. And since it's threaded, and since my Jupyter Notebook is also threaded, most of the time it gets into what? An error. So you won't be able to, stop this particular process. You won't be able to interrupt this particular cell in this particular content. So then I have to just stop it out, and then we will waste a lot of time. So that's why I won't be using cv2.inshow, but you can use cv2.inshow when you will be using a Python script. You'll be putting your things in a Python script. Fine. So let's just delete this one for a second. We won't be using cv2.inshow. So I can say comment out. Then what we will be using? We can use a new module called matplotlib. So the reason why I didn't say you should be knowing matplotlib, because we'll be only using a single function, matplotlib plt.inshow. We'll be using only that, and that's why I said, okay, if you are not aware of matplotlib, then let's just go. We don't need that matplotlib that much. The major stuff is going to be done in NumPy and OpenCV. So let's just you can simply say this pip install matplotlib. You have to run this one, and you have to import matplotlib pyplot as PLT. So this is again a rule. So if you don't follow this rule, you don't import matplotlib pyplot as PLT, then again knife comes out, and you know what happens, right? So you can just simply copy this out. I won't say okay, what is matplotlib, what is pyplot, what is PLT. Let's just leave it, because we don't need much of these things, and it will give me, I guess, some errors, because some of my access over it's taking time. Normally it doesn't. Yeah, so it didn't give it error. So I can just simply say plt.imshow what? My image. Image as my image, then I can say plt.show. This is all I want to do. So here we have the image. But wait a second. why this particular duck is in blue color? If I remember correctly, this duck was yellow color, right? So why is it in blue color? So before discussing why this is in blue and why this particular this is in brown, this wasn't in brown, right? Just look again. This wasn't in brown. Yeah, this was blue, and I guess why it's getting orange or something like that. But before discussing this, let's just look at the shape of the image array. Shape is basically, it says, okay, what is the dimension of the matrix itself? So we have array itself, but array, when we say, okay, we have a two-dimensional array, we call it matrix. So it says there is three dimensions. It's basically three dimensions: 960, 603. You know what this 960, 603 means? It means whatever the array is, there is 960 rows in that array. So let's just not call it array, and let's just call it matrix, and just say it's too low. So if you let me do one thing. Am I audible now? Hello, hello. Am I audible? Hello. Now I guess I'm audible, and but there will be a little bit of noise. So I'm sorry for that. We will definitely make sure that doesn't happen again. So now I guess it's clear. It is, right? Now is it all still? It's still low. It's working, right? I'm sorry. Yeah, it's working, right? Yeah. So I'm sorry for the noise. I will make sure this doesn't happen in the next series, right? So yeah. So image shape. We were talking about image shape. So what is this 960? 960 tells us that there are what 960 rows in whatever array I passed. Yeah, right. So we were talking about, but because most of the people don't know what BGR and RGB is, right? So we were doing that. So 960 rows and 600 columns. But then what is this three? 960 rows and 600 columns. Okay, fine. I know. Okay, image has what? 900 height and 600 width. That's fine. But what is this three? Let's just discuss that three. So how many people know that image basically has three components in it? For each pixel it is. Image is basically a combination of pixels, right? So let's just. Image is basically a combination of what? Pixels. So now what I want to do is, I want to see, I will explain to you people that what exactly an image basically digitized is, right? So let's just look into this. If I say I have an image, let's just make an image. Pardon my drawing. So let's just make this as a person, right? So this is the image that I'm seeing in my screen. So you know what this image is composed of? A lot of small, tiny dots. And what these dots are? Dots are what we call pixels. Fine. These dots basically illuminate to some color, and they all combine together makes what? The image. Fine. So let's just say this particular dot here has color black. So if I zoom in, if I want to zoom into this particular block like this, then you know what's there? There is basically three. You can say, I would say this is basically we are going into displays or something like that, but let's just say it's LED displays or something like that. Then let's just say there are three lights. Fine. So each light has a capability to produce a color. You know what that is? One has R, one has G, and one has B. Right. And this is what RGB is. Like people say, okay, it's an RGB image, it's a grayscale image, okay, whatever you have heard, okay, it's a black and white image. So this is what it means. R, G, and B. And each of these LEDs can glow with some intensity, right? When all of these intensities are combined, then it makes a new color. And according to the RGB color space, any color can be made using the combinations of certain R, G, and B values. Fine. So this is what we have in RGB. So now you see, okay, this is 3. So now you can like pretty much guess, okay, that is 960 and okay, why 560 and then it's 3. So this 3 should be what? This RGB values.
This RGB values is what? Red. So if I say that I have a pixel in this particular location, which is here, its R value is, let's say, 43, and its G value is, let's say, 22, and its B value is, let's say, 120, then it produces a color. And that color is what this particular pixel here is. That's what we see. So if we go back to our Visual Studio and see the image, each of these pixels, each of these small dot pixels has 3 values. That is what it says. 960 rows, 600 columns, and each of these elements in each of these rows and columns has 3 values. So if I want to say, okay, if I want to look at the very top left corner, what pixel, then I will have what? How many values? 3 values. So I say, okay, get me the first row element, first column element. There is 3 values. It's in the top, what? Top left corner, and there is 3 values. What does 4, 6, and 7 means? RGB? That should be right, but it doesn't. I don't know why, but basically OpenCV does a little bit. I don't know why it's so confused, but anyways, OpenCV, what OpenCV does is whatever it sees, it loads it to BGR format, not RGB format. Basically, what it means that for a normal person like us, like all of us, we say, okay, if I look into a pixel, I have 3 values, then the first value should be R, which is the red component. The second value should be the green, and the third value should be the blue. So RGB. But for OpenCV, it's not like that. It says, okay, the first component is blue only. No, I don't know. I don't know nobody. Whatever you do, whatever you talk, I am my own, my life, my rules. So it's first one is blue, then what? Second one is green, and then red. So it's in BGR format. So it basically, I would say it's basically like OpenCV's stuff. So it loads things into B, G, and R. So this particular image, for this particular image, 4, 6, 17 means 4, 6, 17 means 4 is what? B. This is what? 6 green, and our 17 is what? Red. But for Matplotlib is like us only, right? We all are normal person. The Matplotlib is like, okay, I'm so afraid. Okay, whatever you're saying, that's true. I'm only considering the first channel as what? Red, and that's the common convention, right? So, but OpenCV says no, that's not right. So Matplotlib expected the pixels to have RGB orientation. But since OpenCV loaded it into what? BGR orientation, when I provided that image to Matplotlib, it only recognized, okay, it's in what? RGB only. So let's just consider the first value as what? R. Yes, Mike, we can use CVT, and we will use that definitely. So, but before that, we need to know, right? So if you use, remember, if you use cv2.imshow, cv2 and imshow, this particular function imshow, it comes from where? CVT module only. So CV2 knows now how it loads. So it loads into BGR. So cv2.imshow also says, okay, my friend Imread only loaded into BGR. So I'm also going to show the image in the BGR format. So it also shows in BGR format. So the channels are not spacked. But PLT doesn't know. PLT says, okay, you gave me an image, it's RGB only. So what do we need to do? We need to change the orientation. So now I'm going to do a little magic over here. Those people who don't know NumPy and slicing, they will get a little confused. I'm so sorry for that. But this week, I expect you people go through this simple concepts of NumPy, right? You can use another function that converts this. Then that we will discuss in the next line. But first of all, let's just see this. Okay, this just shows this. And let me just copy this one. And I'm going to say inside a cell. And so as our discussion, PLT, what it does? PLT says first channel is R only, right? So I'm going to take everything, the row and column, everything. And I'm going to say, okay, give me the last channel. Last channel in OpenCV array is what? R, B, G, R. So I want the last channel, which is the R. And I'm going to say last channel is what? If I have 3 values, what is the last value index? 2, right? N-1. So 2. And the second value is 1. So B, G, R, RGB. G is always at the correct position. But blue is where? Blue is in the first position. I want it in the last position. So I'm going to say it's in the last position. If I run this one, you would see, voila, we have the image pretty neat. Fine. So now we know, okay, OpenCV loads in BGR only, and we basically want to do things, process things in RGB. But you can continue to do in what? BGR. So then if you do BGR, then what happens? You need to make sure that whenever you are visualizing those images with any other function that's not inside the CV2 module, what do? You convert or you make sure that R is first and B is last. That's it, right? So this is one way of doing this, and this is totally on NumPy. I never used any OpenCV method here. Fine. Well, let's wait a second. Okay, now you're saying, okay, NumPy, we don't know NumPy. No, you are talking about OpenCV. Let's just show OpenCV technique. What's this? So there is an OpenCV technique as well to convert. So these are functions. And now you might ask me, okay, how do you remember all these functions? Yeah, like there are a lot of functions. There actually are a lot of functions. Which will later on. So how do you remember? It's not basically about remembering. You can actually Google it. So if you tell me any of the functions in OpenCV, I can name them. But I still don't remember how they are actually, the arguments, how they are actually arranged. So I need to always go to the OpenCV docs and just say, okay, this particular function is like that. So it's fine to not remember all the functions, but it's not fine if you don't know a particular function exists. That's the problem. That's the entire purpose of this entire series. Most of the things that we discuss here, students don't know that they exist. Like those people who are like very new to OpenCV or image processing and computer vision. They don't know, okay, these kind of things exist because most of the course just skips this part and they directly jump into DL or things like that. So digital image processing is a major part. So you need to know. So at least if you don't remember the functions, you can easily Google it up. But you should know, right? There's something like this exists, and this is what it calls. So if I say, okay, you have to blur an image, you should know what blurring is. But at least you should know blurring exists. And you should even know that blurring this particular thing or using blurring in this particular scenario will work. That's the three things. Functions are not a big thing. You can just write it down in a note, or you can just simply put it in your mind, okay, something like this exists, and then you can later on Google it. So the function to basically do the conversion, what conversion are we discussing here? We want to convert the color space. You know what color space is? Color space is what we're talking about the entire, like from the past, I would say 10 minutes. RGB is a color space. Okay, and grayscale is a color space, and YCBCR is a color space. So these kind of things are color spaces. So you say, okay, where this grayscale and YCBCR come? No, you are all confusing. Just okay. I just want to give it a name so that you can get the essence into it. So what you want to do is you want to convert RGB to BGR, right? So there is a function called CVT color. As our Mayank said, Mayank is pretty much into it, and it's CVT color. So CVT color is the function that we use. CVT is basically, I guess, it's an abbreviation for convert color. So what you want to convert is, I want to say, okay, image. I want to convert the image color to what? So now I need to provide a code. I don't know. Entire OpenCV is based on, you can say, a constants, a code, 0, 1, 2, 3, 4, 5, 6, like that. So we need to provide a code for converting what? My BGR image to RGB. So how do I do that? I say CV2 dot color BGR to RGB. What this is, let's just look into this just for a second. This is nothing but a simple integer, which is 4. So that you don't see, if they say, okay, 4 is for BGR to RGB, just remember that. And then they put out their docs as never mentioning about color BGR or to RGB, and they say, okay, 4 is what you have to use to convert color. You will never be able to remember it, right? That's why they just saved a constant called color BGR to RGB, which is 4. So this function is made in such a way that if it gets a 4 argument, it automatically recognizes, okay, it's BGR to RGB. That is what the programmer wants. So I would say, okay, I need this as RGB image. It's a CV2.CVT color. Now I converted it, right? So now according to theory or according to whatever I told you in the past 10 minutes, this RGB image should be RG and B, not B, G and R, because that's how we want to convert it, right? So now I say, so if I say image RGB image without doing the column switching or column swapping, this should be the normal yellow duck, right? And that's how you basically do in OpenCV. OpenCV provides a method, but this method is not really for BGR to RGB, as you might have guessed. There are a lot of color spaces, and you all can change these color spaces using CV2 colors. And you can actually go to gray as well. So we definitely will be using gray. So let's just come back for a second and just look back into the image array again. So what is this image array? You know what D type is? This is the NumPy specific stuff. B type is basically what is the type of the array itself. Unsigned int 8-bit. Remember, whenever we are talking, there are multiple types of images. There can be multiple 16-bit and 32-bit, but 8-bit images are basically what you will see most of the time. Most of the time, everywhere you see, it's an 8-bit image. What is an 8-bit image? Okay, if I say 8-bit, how many different combinations, different permutations I can make using 8-bit? Every bit can have a 0 or 1. So how many values I can have? Different values. 2 to the power 8. 2 into 2 into 2 into 2, like total 2 to the power 8. So 2 to the power 8 is what? 256. So I can have 256 different values for an 8-bit, small 8-bit integer, unsigned 8-bit integer. Fine. So now this unsigned 8-bit integer is what corresponds to a single what? Pixel. So if I have a pixel, my pixel is what? 3 values. So if I say image, again going back to the leftmost corner, pixel, it's a 1 cross 3 array, right? It has 3 elements. So if you see closely, it says D type uint. So this particular element is also what? D type, and each of these elements has a type what? Unsigned integer 8-bit. So what is the maximum value you can have? 256. 256 values you can have, different combinations you can have for a particular 8-bit number. So remember, whenever I'm talking about a particular pixel and a particular color pixel, if I say, okay, you have, let's just go back to this discussion and just say, okay, we have 3 pixel, a single pixel here with 3 color LEDs, right? So each of these values can take, you know what, 0 to 255 values. I can have like total 256. 0 counted, it's 256 only, right? So total 256 values I can have in this type of values, different permutations. So that's why whenever I say 255 for a particular pixel, it means that the highest intensity this particular LED can have. What's highest intensity this particular red color can have. So if I'm using this particular what this is our pen. So if this pen color is red, right? So it just means that whatever my screen is showing me has a pixel value somewhat like this, because it's red. Only red is what I want. Fine. So for the green, what would I say? I would say, okay, green, I would say 0, 255, 0. And for blue, what would I say? 0, 0, 255. So it can be between 0 to 255. So now tell me, can you guess what black would be? Black is absence of any color. Absence of any color. So what is the minimum value I can have in all of these values? All of these 3 pixels? It is 0, 0, 0. And what is white then? White is presence of all colors. So what all colors we have? R, G, and B. So it is white I can actually show you. It's 255, 255, and 255. We have the white pixel. So let's just do one thing. If that's true, let's just go back and just simply visualize the R channel of the image. R channel. I go over this and say, okay, I need to show what? The R channel. What would I say? I will say, okay, this is my image. I just need all the columns. Before that, you have to copy this. I would say that image is nothing but np.post image. What I did is basically I made an image with all values as 0. So if I say and all values as 0, so what will my image look like? np.0 is like basically what it does is it looks at the shape of the array that I passed and the type of that particular array. And what it makes is it puts all the values to 0. So whatever my red image is, it's nothing but total 0. So see, everything is 0. There is no value in this. That's what np.0 is. Okay. So what I say is, okay, red image is here. So I just want to change what? Just take the red component of my image. The red component is the first channel, right? So everything, every row, every column, and the first channel should be equal to image. First channel. If I say now plt.show red image, plt.show you will only see the red components, just the red components, because I just zeroed out all the other what? All the other components, all the other color components. So now you might ask, okay, if that's so clear, then why didn't you use this realt.imshow? You might be thinking, right? Why couldn't I use this? It's something different. Then we will actually discuss this when we'll be talking about color maps. So that's why I never did this. So when we were talking about grayscales, and possibly will be in the next lecture or maybe in this lecture as well. This grayscale, when we're talking about grayscale, at that particular moment we'll come back to it, right? So let's just comment this out this time. This is the R. So if that's so clear, then what is B? I can just simply say, okay, blue image is what? Everything, R, G, and B. B is the last. Last is this. Let's just make more images, blue and green. So just need to make this and green image. Green image, and if I run this one, and I just have to simply say, okay, after the blue one, I need the green one. So this would be one, right? Green image, red image. I just copy it out and I said blue image, and then the green image. Fine. So there is not much green component in there. There are there are not much green components in there, and blue is also okay. Fine, blue. You are seeing some fits in there. That's all blue components in there, right? So this is the red one, it's the blue one, it's the green. Fine. So now what? So this is what we actually saw in the east channels, and when these all are combined together, it produces a new color, and that's the entire exact color what the image is all about. Fine. So now we talked about RGB and BGR. Now comes the major and the most interesting part, or the most important part, is grayscale. Grayscale color maps. Fine. I need to check what grayscale color maps are. Fine. So before grayscale color maps, let's just go back. You know what grayscale is? Grayscale is again a set of pixels. Let's just consider this as pixels. Fine. But that particular pixel has only one LED, and the lowest color it produces is black, and the highest color it produces is white. That is a simple white color, and it has intensities from black to white, a normal, you can say, fluorescent bulb kind of stuff. Fine. And the maximum value is 255. It means that when that pixel value is 255, it will be white, and the pixel value is 0, it will be black. Fine. So now what we have to do is, grayscale is a new color map or a color space, and what in the grayscale images does not have RGB. They does not have RGB. They just have a single pixel, just a single pixel. Single pixel means if my array is of a grayscale image. So in this case, RGB image, what I had? I had height, I had width, and I had channel, which is 3. All images have height, width, and channel. But in RGB or BGR, it had 3 channel. But in grayscale, it has only 1 channel, which has values from 0 to 255. Fine. So grayscale basically crunches down the entire 3 space to a 1 space. So now I'm going to put in some, come up with some linear algebra, or not only linear algebra, it's just Euclidean space and Cartesian space. Let's just assume for a second that okay, whatever vectors I had, whatever values I had, 3 values, A, B, and C. This is for R, this is for G, this is for B. Let's just consider this A, B, and C as a vector. So if it's a vector, then it would be in a 3D space, right? As R, G, and B. And if I plot this ABC somewhere, let's say A is here, and B is here, and C is here. This is somewhere here, okay? Here. This particular vector corresponds to what? A color. I hope you are able to imagine this. This particular pixel corresponds to a color, and this color is what? Are 3 values. So now this space is an RGB space, and I want to convert it into grayscale. So grayscale has only one value. So you can pretty much say it's a real line with 0 and 255. So I need to take all the vectors in this 3D space to this 1D single line or 1D real line. Fine. So it's like this particular vector maps to this area and this particular vector maps to this area, and 255 will be when all of these components has highest value. So it will map to this area. So that's how basically in essence what grayscale basically is. But that's too basic, and we are not supposed to discuss all two basics because I consider you people have a little bit of knowledge about a little bit of image. So we don't need to go that deeper. So again, grayscale is a color space. Color space. What I want to do. I can use again what? CVT dot. And what I need to do, I need to produce the image. And then what? CV2 dot color. Remember, this is not BGR this time. This is in RGB to gray. RGB to gray. This is an RGB to gray. So now it gave me an RGB to gray image. So I would say, okay, gray image. So whatever we discussed is true. Then gray shape should be what? 960 cross 600 cross 1. So if it's 1, if it's not written, then it's automatically obvious that it's 1. So it just has height and width and a single channel. The single channel has maximum value 255 and minimum value 0. Fine. So this is what gray image is. So if I want to show this to my matplotlib, I need to explicitly tell this particular thing that use the color map gray. And you will see it's the gray image. You know, brightest spots are white and darkest spots are black. That's what grayscale is. So now this is all about the introduction to some images itself. No image processing. We have not done much. We have not even started the real thing. So this is just the introduction. So this was totally for those people who are very new to this. Right. So I guess this we can conclude this one with this one. This is just the introduction, and this is what you must at least know before continuing with the entire series. You can find this notebook in the next. I will provide a link to the GitHub for this particular notebook, and then on the next upcoming lectures will be uploaded in that. Notebooks for the upcoming lectures will be uploaded in that particular GitHub only. So the first lecture that we wanted to was introduction to digital image processing, and it was just simply getting familiar with OpenCV. Fine. So just reading and writing. That's what it's all about, getting familiar and just converting some color spaces. That's it. So the next lecture will be on filtering images, and filtering images we'll be using again OpenCV, but we'll be discussing the algorithm. So what's different other than just simply using a bunch of OpenCV functions is, see here I just simply show you, okay, CVT.color, this CVT color changes the color space. Fine, that's what I told you people. So CVT.color actually does it, and I never told you that how does it does is basically averages it given some and gives some weightage to the green component, but that's not very necessary because those functions can be easily used, and it's very simple to understand. If you go over to a blog and you will get it, okay, what is color space and how things are converted. The real essence part is all these algorithms that are in the coming lectures. And there, I won't be simply saying, okay, for blurring, you can use cv2.filter 2D, and this is how we do it. I won't be saying that. But we definitely will be implementing this particular algorithm or blurring algorithm using that particular function. But we will be first discussing every pieces of whatever it takes to learn blurring and obviously sharpening. So what is blurring? What is, first of all, filtering? And how do we filter an image? What is basically meaning of filtering? And you will get a complete with what convolution operation is, and what is how many types of blurrings there are. So these kind of theoretical stuff we will definitely cover, and that is what is different and unique in this particular series. I don't want you people to just simply know, okay, we can blur using this function, and this is how this function is used. No, we'll be talking about how this is done and why this is done. Fine, and we'll be discussing the algorithm, and then we're simply implementing that using OpenCV. We can implement that from scratch as well, but we have time limits. We only have 1 hour, right? So we can't just do everything. Fine. So what you can do is in every Saturday and Sunday, we'll be discussing some algorithm. I'll be providing you the algorithm. So what you have to do is you can code that in any of your favorite languages. It's always better if you do it in Python because it's very simple. So you can do that, and you contact me anytime in the weekend or in the weekdays, so that if at all you are ever getting stuck in some places where you want to implement. But I would definitely recommend you people to implement all the algorithms that we discussed. So today we did nothing. We just simply introduced to whatever we're going to see in later on and whatever we need. So for like, if I give you a task for the entire weekdays that you're going to have the next week, what you have to do is get familiar with Jupyter Notebook, get familiar with Python, get familiar with the basics of OpenCV. Nothing, just reading, writing, and color spaces, how to convert color spaces, and get familiar with NumPy and slicing. There is nothing more needed, just NumPy and how you do slicing in NumPy. That's it. These 4 things are the prerequisites, and I just give you an introduction, just a pinch of salt or something like that. Just that's it. And that's why this was pretty simple as well, because in the starting 15 minutes we were discussing about what we want to do, right? This is just simple introduction. It was like those people who are very new to this, they get an essence, okay, what they should expect. So in this week, I expect you, all of you, all over whatever you people are, if you have expertise, then super good. You can just directly come in the next lecture. But if you are very new to this, all these 4 things are required. Just go through this. You will get a lot of cheat sheets. You will get lots of blogs. You don't need to read an entire 1-hour blog. Just simply go through the top steps and you will get, okay, these are the things. Just get accompanied to these concepts. And then so that we can start with the real thing that we want to do. Fine. And if you people are not very clear, then you won't be able to get all these lectures and you won't be able to ask questions. The best part is asking questions, because you can actually learn all of these things in a blog. And you will just have to find, okay, is there a comment that actually addresses my issue? And if it doesn't, okay, you have to put a comment. And most of the people are very, they're like, okay, I want to comment. Okay, what if somebody sees, things like that, right? So the major part of a live webinar is people can ask me questions, right? So that is why I want you people to get accompanied, so that whatever is getting delivered to you, you can take in it 100%, and then you can process it. Then you can ask questions or answer the questions. That will be a healthy discussion, right? It won't be a simple webinar. It will be a healthy discussion as well. So that's what I expect you people to have in the next, which is Saturday, 5 p.m. same. So for this one, we can conclude this here, and you can find this notebook. We have not done much in this, so I will upload this and provide you the link later next week. And then so the next lecture we will simply seeing what filtering in images are. So either you can just give it a go at, okay, what filtering is, so that you can be like, you can show, okay, I know things, or you can just come down with all these 4 prerequisites I just already told you. And one thing for sure, I will make sure that this particular audio issue that we faced today doesn't happen again. So sorry for that as well. And thank you for being, I don't know, yeah, sure, man, sure. I already told you, only 4 things you need to know, only 4 things, only 4 prerequisites is that you need to know: Jupyter Notebook, Python, NumPy, and a little bit of OpenCV, like reading, writing, and color spaces. And NumPy also just slicing. Because wherever machine learning or deep learning comes in, we will have a lecture and just to touch it over, so that you won't feel like, okay, whatever it is, I don't get it. You don't get ghosted out, right? So that's fine. Fine. And those people who know machine learning and who are like, okay, I don't know much about image processing, then they also can join, because when the machine learning part comes, you already know what things are actually done here, right? So just 4 things that's required. That's the prerequisite. There's nothing else required. And we will meet next Saturday at 5 p.m. same time. But today is Sunday, right? So yesterday was Diwali. That's why we all were enjoying, right? So yeah. So I hope this one, and thanks for sticking around. And I guess we can conclude, right? So okay, guys. Is it time to say good night or something like that? Okay, good evening, whatever it is. So thank you for joining in, and we will see you next Saturday. Bye bye.